Hello class, welcome to exercise 1H, where we're going to find the length and midpoint of line segments. I have to make one admission, and that is that I really love this topic. Okay, this is one of the funnest things we're going to do in this unit. I also have to make an apology. There is a dog barking in the background, so if that comes through in this video, I apologize. Hopefully it doesn't. Alright, so the examples that we'll be doing in this exercise, and of course the pre-learning that follows it, is example 22, which will be finding the distance between 2 points. And your questions for this are questions 1 and 2 in the new book and questions 4 in the old book. Then we'll do example 23, which will be finding the midpoint of a line segment that joins 2 points. And your questions will be question number 3 in the new book and question number 5 in the old book. Then finally, we'll do example 24, which will be using a given distance to find coordinates. And your questions will be question number 6 in the new book and questions number 8 in the old book. Please pay close attention to this topic, as a number of the questions on our topic test will be inspired by this. This topic brings up some interesting challenges that are definitely worth testing you out on the difficult conceptual questions for the topic test. To do well in those sorts of test questions, please note I will give a number of challenges in this topic. Those of you who are capable of doing these, I'll be signing up for Specialist Maths straight away. Let's move on to our brief introduction. I know I've said there will be a number of challenges in this topic. However, it's important that you know that we're just using similar ideas to finding an equation. And though I've said it a few times, it's worth writing down that these are important skills for many challenges you're going to end up using in maths. So make sure you take good notes to understand and memorize these skills. Also note that I'll be doing the examples in a slightly different order to how I introduce them, but this is so they make more sense following on from one another. Anyway, let's get on to the first section. In this section, we're going to learn how to find the length of a line segment. Another way of describing what we're doing is finding the distance between 2 points. So here we have 2 points, A and B, and A is equal to x1, y1, and I'll mark x and y on the graph, and point B equal to x2, y2. And I'll also mark those on the graph. So before I go on with the lesson, I'm going to ask you, how would I find the distance D, that is the length of this line segment between A and B, which I'll mark D on? Pause the video and have a think. Okay, did anybody come up with Pythagoras' theorem? If I look at what we know as the run and call that A, and then the rise and call that B, then we have a right angle triangle here. And by the laws of Pythagoras' theorem, that would mean that D squared would be equal to A squared plus B squared. And as we know that A is equal to the run, well, that's just equal to x2 minus x1. And because B is equal to rise, well, that's equal to y2 minus y1. Before I sub in the x and y values for A and B, let's just remember that if D squared is equal to A squared plus B squared, then D will equal to the square root of A squared plus B squared. So if I'm now to rewrite that, including the values of A and B using the x and y values that we already know, then D is equal to the square root of x2 minus x1 in the place of A, but still all squared, plus y2 minus y1 in the place of B, but still all squared. And let me make sure that square root covers it all. So now I can find the length of that segment, or the distance between the 2 points, just using the x and y values from the 2 points. Make sure you notice that the points x2 and y2 both come from B, and the points x1 and y1 both come from A. But hopefully the colours make that really clear. Okay, let's move on to example 22 to put this into practice, where they ask us to find the exact distance between a pair of points. There's 2 sets here, and the set in part A is a point at 0, 2 and 1, 7. So here we'll just use the formula, which will be D is equal to the square root of x2 minus x1 squared, which in this case is 1 minus 0 all squared, plus y2 minus y1, which in this case is 7 minus 2 all squared, which is equal to the square root of, so 1 minus 0 is 1 and 7 minus 2 is 5. Just note that I've left the brackets there because sometimes it might be negative, and this is just a habit I build up to make sure that I don't get confused when we have negatives. Okay, so 1 squared is 1 and 5 squared is 25. So this is equal to the square root of 1 plus 25, which equals the square root of 26. Now the question asked me to find the exact distance of the pair of points. So the real answer is the square root of 26, because estimating in a calculator is not exact. However, you may want to know what the square root of 26 is. I'm sure you'll know it's near 5. Let's use the magic of OneNote to find out by using the maths function. Now selecting an action, the only action there is to evaluate, so let's choose that. And now I can drag this onto the page. Okay, so yes, as you can see, the square root of 26 is close to 5. So let me just quickly draw what this would look like in a graph with the L-shaped axes. So I know that the length of that blue line is the square root of 26. Okay, let's move on to part B. Here the 2 points are minus 3/8 and 4 minus 1. Let me quickly draw a graph and place these points on it so we can have an idea of what we're trying to do. Alright, to get back into the algebra, the distance between these 2 points is equal to the square root of x2 minus x1. In this case, that is 4 minus minus 3 all squared, plus y2 minus y1, which in this case is minus 1 minus 8 all squared. And because 4 minus minus 3 is equal to 7, and minus 1 minus 8 is minus 9, then we now have the square root of 7 squared plus minus 9 squared. So you should be able to see why I've used the brackets. It'd be very easy to get this minus 9 wrong. So anyhow, 7 squared is 49 and 9 squared is 81. So this is now equal to the square root of 49 plus 81, which is equal to the square root of 130. I'm not going to waste any time on trying to evaluate that. I just know that 11 squared is 121, 12 squared is 144, so the square root of 130 will be somewhere between 11 and 12. But the length of this blue line here is a square root of 130 as the exact answer. And you can see that 7 is the run here, and that the rise is minus 9. So buried deep in this idea of finding distance between a line segment is rise over run. So now you know that it's doubly important. I just want to point out that drawing these graphs are purely to help you visualize the line segment. You only need to use the formula in a test. Just make sure that the run is in one bracket and the rise is in the other bracket. Okay, so you can practice applying these skills. Go ahead and do questions 1 and 2 if you've got the new book, and question 4 if you've got the old book. And I'll see you in the next section. In this segment, we're going to use a given distance to find coordinates. What if you were given a point and were then asked to find which points on the line have a particular distance from this initial point? As you think about that, it is quite challenging, isn't it? But this has many applications in the real world. So as we do these types of questions, you're just going to need to use the formula for distance and apply it intelligently to the information you get. Sometimes drawing the graphs and adding lines in will help. I think if I try and give you too much algebra now, it'll just confuse you. I think it's best if we just move straight onto the example and you'll have a look at what this sort of question is. So let's move on to example 24, where we're asked to find the values of A if the distance between 2A and 49 is a square root of 5. Note that they've asked for values, i.e. plural. So why would they be saying plural? I think the only way to really see this is to have a look at a graph. So let me quickly draw this graph. And mark in the point 4, 9. What does it mean for a point to have 2A? Well, what we do know is that its x value is 2. So that means it must be somewhere along this line. So we need a distance of square root of 5. This segment here goes from 4 to 2. So it has a length of 2. So that's not the square root of 5. So it can't be that one. So it must be one that goes on an angle like so. And if that had a square root of 5, then there would have to be another line like this that would also be a square root of 5. And then we'd end up with either this point or this point. And their heights would be our a as the y value in the point 2a. Also, when we're finding the square root of numbers, there is always two numbers. So let's use the formula and write it out as we learnt it to start with, which was d equals the square root of the run, or x2 minus x1 all squared, plus the rise, which is y2 minus y1 all squared. And then now we can sub in the numbers that we're given. So our distance is the square root of 5, and that's equal to the square root of x2 and x1. And in this case, x2 is 4 and x1 is 2 all squared, plus y2 minus y1. And in this case, y2 is 9, y1 is a. Hopefully my 9 and a don't look too similar. And of course, that's all squared. Oops, and I forgot the plus sign. Okay, from here, I'm going to square both sides. So now we have 5 is equal to 4 minus 2 squared, which is 2 squared, plus 9 minus a squared. And if I subtract the 2 squared, or 4, from both sides, we end up with 1 is equal to 9 minus a squared. So if I take the square root of both sides, it gets rid of the square on the right hand side, and we're left with 9 minus a. But on the other side, if I take the square root of 1, don't make the mistake of thinking that is just 1, because yes, 1 squared is equal to 1, but also minus 1 squared is equal to 1. So we do this fancy thing where we say plus minus 1. So the square root of 1 is 1 and minus 1, which really means that 9 minus a is equal to positive 1 and 9 minus a is equal to negative 1. So for this top one, if I add a to both sides and subtract the 1 from both sides, I end up with a is equal to 8. And for the bottom one, if I add a to both sides and add 1, then a is equal to 10. So to get this question right in a test, you need to give me both answers. Okay, you need to understand that about square roots. And if we go back to our graph, it makes perfect sense. Okay, so I can now redraw this with a equal to 10 and a equal to 8, and draw those line segments that are a distance of root 5. Yes, this is very challenging, so you need to get on and do question 6 in the new book or question 8 in the old book. So pause the video and do that. And when you come back, I have a challenge for some of you who are brave enough to try before we go on to the next segment. Okay, so you're back for a little bit more fun. You can skip this if you want and go straight to the next segment, but those of you who try this now are tracking towards specialist maths. I also warn you that there is a good chance there'll be something like this question on the topic test. Okay, let's have a look at this challenge. But please make sure that you've completed the pre-learning for example 24 first. Okay, brave soldiers, here is the question. I want you to find the points on the line y equals half of x plus 1 that have a distance of 5 over 2 from the point 1, 4. Of course, you're going to have to use the formula, just like we've done in example 24, but I'll give you a hint on how to approach this problem. So if a point is on the line, y equals half x plus 1, and we have a point that has an x value of a, then what is its y value? i.e., it's a point with a, comma, question mark. Okay, that's enough for this segment. I'll see you in the next segment. In this section, we're going to be finding the midpoint of a line section that's joining 2 points. Okay, let's start by drawing a graph. Now, if I have 2 points A equal to x1, y1, let me mark that on the graph, and B equal to x2, y2, let me mark that on the graph. And now I'll put a line segment between them, and let's mark in the x and y values for A and the x and y values for B. Then what is the point that is exactly halfway on this line between them, called the midpoint? Let me mark that in on the graph. Let's notice that M is a point with X value xm and Y value ym. We can notice that xm is halfway between x1 and x2, and ym is halfway between y1 and y2. Now how do I find the middle of two numbers? Well, the fact is that a plus b divided by 2 is the middle of a and b. Now I could ask you to just believe me, but let's test that with a few numbers. So 9 plus 11 is equal to 20, and 20 divided by 2 equals 10, and 10 is the middle of 9 and 11. That adds up to 10, and 10 divided by 2 is 5, and 5 is the middle of 0 and 10, or halfway to 10. And one more, minus 2 plus 2, well that equals 0, and 0 divided by 2 is also equal to 0, and 0 is the middle of minus 2 and 2. So it tends to always work with numbers, but just believe me, it does work, okay? So this means the middle of x1 and x2 is equal to x1 plus x2 divided by 2. And this is equal to xm. And similarly, the middle of y1 and y2 is equal to y1 plus y2 divided by 2, which is equal to ym. So the formula you can write down is, if I have 2 points, A equal to x1, y1, and B equal to x2, y2, then the midpoint M of A and B can be formally written as M is equal to a point with X value x1 plus x2 on 2, and Y value y1 plus y2 on 2. This is a very important fact because this is how we find the middle of any 2 points on the Cartesian plane. At the end of this section, I'm going to leave a final challenge for everybody, and we'll get to go over that in class as well. Doing this challenge will make it clear why this rule has to be true. But before we think about trying to prove that a rule is true, let's get on with an actual numeric example, and we can do that with example 23, where they ask us to find the midpoint of the line segment joining the point -3, -5 and the point 2, 8. Okay, let's just get on with the algebra. So the midpoint is equal to x1 plus x2 divided by 2 for the x value, and for the y value we have y1 plus y2 divided by 2. So in this case our x1 and y1 will be the yellow point, and our x2, y2 will be the orange point, 2, 8. That means that this is equal to -3 plus 2 divided by 2 and -5 plus 8 divided by 2. So -3 plus 2 is -1. So our x value is -1 on 2, which is -1/2. And our y value is -5 plus 8, so that's 3 divided by 2. So that means that the midpoint of the line segment joining -3, -5 and 2, 8 is -1/2 and 3 on 2. Let's have a look at that on a graph. So let me mark in the point -3, -5 and the point 2, 8 and draw the line segment between them. Okay, so our calculations tell us that the midpoint has an x value of -1/2 and y value of 3 on 2, which is 1/2. And sure enough, that turns out to be true. So you can be pleased to know that I'm not lying to you. Okay, so you need to go on and do your examples. So students do questions 3 in the new book and questions 5 in the old book. And when you come back from that, we have one more challenge to talk about, which you're welcome to go ahead and do now, but we will be doing it in the class if you don't. Okay, welcome back, and let's have a go at our final challenge. This final challenge is a great way to check all of the rules and skills that we've learnt so far in this unit. It'll also confirm to you that everything we're learning is true. Okay, so here's the question. Take 2 points, A equal to -3, 8, and B equal to 2, -5, and find the equation of the line between them. B, find the midpoint of A and B. C is the midpoint on the line, and I want you to confirm that by checking with the equation. And D, find these 3 distances. A to M, M to B, and finally A to B. And for E, I want you to say what this tells you. All right, there's the end of the lesson. I think it was a fun lesson. There was some heavy lifting, so make sure you work hard on your pre-learning, and I'll see you all in class. See ya.